Hi, grade 12s. We're going on to question 4 from the Sequences and Series handout. Okay, so this question is from the IEB Final 2019 paper. So it goes on to question B1. It says an arithmetic series has a first term of 3. So write that down. First term is equal to 3. And the last term is equal to 47. So we have the last term is equal to 47. And the sum of all the terms is equal to 300. So we have the sum of all these terms is equal to 300. Okay. Determine the number of terms in the series. So we know what the first term is, and this we can also say A is equal to. We have the last term, and then we have the sum of however many terms there are is 300. So the formula that I'm going to use, because we're given A and L, is I'm going to be using this formula here. Sn is equal to n over 2 a plus L. Okay, this formula is not on your formula sheet, grade 12s. You need to know this one off by heart. Okay, so basically what I can do is I can just substitute everything in here. We know that Sn is equal to 300. So that means that we're going to get n over 2 a plus L equals 300. I know what my A is, it's 3. I know what my L is, it's 47. So we get n over 2, 3 plus 47 equals 300. Okay, so I'm going to miss a few steps here, but I'll explain what I'm doing. So first thing I'm going to do is I'm going to take 300 and I'm going to divide it by 50. Divide that by 50. Then I'm going to multiply up by 2. Okay, and we get n is equal to 12. So we sum 12 terms. Now it's asking us to determine the common difference for this series. Okay, so if I have a look here, I know how many terms I have. I know I've got the first term, and we just don't know what D is. So what I'm going to use here is I'm going to use this formula. Sn is equal to n over 2 2a plus n minus 1 times d. Now let's have a look. See, we know what n is, n and n, we know it's 12. We know what a is, it's 3. N we know, d we don't know. Okay, and also we know what Sn is 300. So that's what I'm going to do here. I'm just going to say that Sn equals 300. So we get n over 2 2a plus n minus 1 times d equals 300. Oh yes, and grade 12s, this formula is on your formula sheet, so you don't need to know that one off by heart. Okay, so we know what n is, it's 12 over 2. 2 times a, which is 3, plus 12 minus 1 times d, we don't know what that is, equals 300. All right, so if you follow what I'm going to do, I'm just going to miss a few steps, grade 12s. So first of all, I'm going to say 300 divided by 6, because we've got it from here. Okay. Then what I'm going to do is I'm going to subtract 6, because we've taken it to the other side. And this is going to give us 11d. So 11d is equal to 44. I can divide through by the 11, and we get d is equal to 4. So we've got our common difference. Okay. Question C. It's asking us to calculate the sum, or sigma, n is equal to 2 up to infinity of 4 times 1 over 2 n plus 2. So this is a sum to infinity problem. So our formula for that sum to infinity is equal to a over 1 minus r. Okay. Remember, always with sigma, always expand it, write out your first 3 terms. So we got to start at 2, so I'm going to put 2 in there, and we get 4 times a half, and if I put 2 in there, I get to the power of 4. So that's our first term, plus 4 times a half. Now I'm going to go to 3, so that gives us 5, plus 4 times a half. So now I need to go to 4, which is 6 plus, and we carry on and on. Okay. Now, in order to use this formula here, we need our A and we need our R. Our A is our first term, and then our R would be T2 divided by T1. Okay, so what I can do here is I can just quickly work out what our A is. So we get 4 times a half to the power of 4, and we get a quarter. Okay, our R would be equal to T2 divided by T1. So here we get 4 half to the power of 5 divided by 4 a half to the power of 4. Okay, so the 4's will cancel, and then 5 minus 4 is 1, so our R is a half. Okay, I've got my A, got R. We can now find the sum to infinity. So sum to infinity is equal to A over 1 minus R. Sum to infinity is equal to A is a quarter over 1 minus a half. Okay, so 1 minus a half is a half. A quarter divided by a half is a half. Okay, just make sure of that. And yes, it is. Okay, so there's your sum to infinity. Right, question D. Question D is saying, in a geometric sequence, the third term is 5p plus 1. The fifth term is 4, and the seventh term is 1. Determine the value of p. Okay, because we're dealing with a geometric sequence, I know I'm going to be using this formula. Tn is equal to A times R to the n minus 1. That is given on your formula sheet. So if I expand this over here, if I put 5 into the n there, that means on that side I'm going to get AR to the 5 minus 1 equals 4. Likewise, I'm going to do it for the 7. Plug 7 into there, so that becomes the 7. So we get AR 7 minus 1 equals 1. I'm just going to simplify this. AR to the 4 equals 4, and AR to the 6 equals 1. Okay. For this one here, we can get AR to the 3 minus 1 equals 5p plus 1. Simplify it, and we get AR squared equals 5p plus 1. All right, so grade 12, so we've got 3 equations here now, 1, 2, and 3. What I'm going to do first is I'm going to leave this one for last, okay, because this one is a bit of a problem. We've got 3 unknowns, A, R, and P. I'm going to work with these 2 over here. So if I call this equation 1, equation 2, and then equation 3, okay. So this is very similar to one of the questions that I did in the first video. Okay, so if you go to the first video, it'll be in there. I think it's the first video. Let me just make sure. No, it'll be the second video. Okay. So what I'm going to do here is I'm going to take equation 3 and I'm going to divide that by equation 2. Now the reason why I'm going to do that is because if I take this divided by this, my a's will cancel, which is good because then we're eliminating one of the variables. Okay, so we've got here AR to the power of 6 over AR to the 4 equals 1 divided by 4. So it's this divided by that equals that divided by that. Okay, so here you can see the a's will cancel. Then you've got r to the 6 divided by r to the 4, which is going to give us r squared equals 1 over 4. Okay, then I can just take the square root. So we get r is equal to a half. Now, I'm just going to change this question around and I'm just going to put a restriction in here and just say that r must be greater than 0. The reason why I'm going to do that, grade 12, is because remember, if you take the square root, it's always plus or minus. Okay, so I don't want to go down that road where we have to do 2 sets of solution for r. because we would get a negative root and a positive one, which we don't want to do that. Okay. So now that I know that r is a half, I am now going to substitute in either 2 or 3. It doesn't make a difference, just to find out what a is. So I'm just going to say sub into 2, and we get a half to the power 4 equals 4. So I've just taken that value, plugged it into there. So we're going to get 4 divided by a half to the power of 4, and we get a is equal to 64. Okay, so now that I have both our a and our r, so here's our r, here's our a, I can now plug it into 1, and then we can find out what p is. So sub both of these, sub a and r into equation 1. So our a is 64, our r is a half, squared equals 5p plus 1. I'll just substitute all into there. Okay, so over here I'm just going to miss a few steps. We've got 64 multiplied by a half to the power of 2. I'm going to subtract 1 from that, and we get 5p is equal to 15. So p is equal to 3. And that's our solution, grade 12s. Thank you.